All right. So before I get into today's problem, day 4, I want to change how the first 3 days are working. Yeah, so right now they just kind of read their own input and print their own output. What if we pass them the input and then they return a struct and we print that struct? Yeah, let's see. So day 1, we'll take string input and it would return, well, in this case, it would just return a number. And whatever it's calling it, which, well, here is nothing's calling it because it's like generated code. So generated code has to change. So we're calling it in like call all function will start with here. It's called here. And here is where we want to, maybe we don't actually want to call all the functions that with here. Maybe we just want to enumerate them and put them into a list. Just a list of strings. Statically, can we make that happen actually? Can we create a static array of all of the functions that start with here? It's just like a string array. It's like give me all the names. Enable preview. Yeah, give me all the names of all of the functions that start with here. Well, first of all, I think this is how you do a static array, right? So before we actually start modifying, let's just revert this. Is there a command to open that diff? Close all diff editors, open all changes, open changes. Open changes. No. Well, like this thing, like what, anyway. Okay, so does this work? No. Because that expression uses, this expression does not use JC. But can it infer? No. No, okay, what about like that? Is that a thing? No. I mean, the compiler knows how big this thing is. Like, why can't you just do that? Like, this is fine, right? Yeah. Okay. Okay. Anyway, we want one of these, but that has this array. So the array we can generate. Well, we can kind of generate. Can we? Okay, so there's two things here. There's this number of functions that start with here, and then there is the actual names of the functions that start with here. Okay, so if we run a loop like this, is it going to? I mean, well, it is a constant. Can it somehow just give us the number, like n? I mean, we can definitely do this, right? Long n equals 0, like that. And then we'll just insert this code for every, right? Well, again, we don't even need to do that really. We can just compile that and then go to the debugger. Yeah. and navigate here and just look at these locals. So locals, we've got n3. Yeah, so yeah, but it just added to itself 3 times. That's okay. Let's look into decompile time evaluation. D-lang, well, like tour. D-lang tour. Gems. Compile time. Compile time function evaluation. Yeah. Static. Immutable enum instructs to do compile time function evaluation. Yeah, so I guess if we just wrap it in a function, if we just do this in a function, let's see, long temp, let's just return n. Okay, can we do like, well, I mean, const n is temp. Okay, does this work? It does. It does, but this I also want this to be known at compile time, right? So static immutable enum. So oh my god. So like static. If I do static, like does this work? Yes. Okay, so if that's so this function is never called. Yeah, well, let's see. Yeah, it's never called. So n, well, n isn't even in here. Okay. Can we do static n like that? Cannot be read at compile time. Well, const. Yeah, okay. Static const can be read at compile time. Can this be read at compile time? Okay, so this still does it at compile time because the compiler knows that this is 3. Okay, all right. Well, I mean, I also want to know the names of those things. Well, actually, can't it just return the array? But we don't know how big the array is, so no. No, it can't really return the array. So if we just do const here, I guess this just runs at compile time, like count all functions that start with year. And just fill this with 1, 2, 3. Okay, so that compiles. And how does this look in a debugger? Well, actually, let's put a few breakpoints. Okay, so n is 0. Okay, so you do call it. N is 3. Okay. Okay, so the function doesn't end up being called. What happens when this is static? I mean, it still compiles. N is not here. N is not here, so it just got fused in here then? Yeah, it just steps over it. So test is just, well, it's here, right? Well, there. All right. Okay, so static does make it evaluate at compile time. Okay. I mean, we can just like do that even, presumably. That's what happens anyway. But how do we fill the array? Year function names. Well, I mean, I guess we can like iterate like this again and just set the elements. Like, well, we do need to keep track of the. We do need to keep track of things, though. Okay, well. Okay. Well, yeah, it's like long I0, and then this would have to be like I++ equals. Does this compile? Yes. No. No. What's the external memset? Memset 128 is unresolved. Well, why is that my problem? What? I mean, that's a C standard library function, if anything. So what am I supposed to do about that? Terminal process, dub, build, debug. Yeah. Wait, what if I, hold on. What if I run this from here? Yeah. What if I run this from here? No, it still doesn't. Okay, I mean, this should really be provided by the compiler, not by me. I mean, I guess like if we can track down where that's located, then we could. Yeah, we want this specifically. Okay, that's like no one's ever had this problem. Okay. I'm guessing it's like it's not even. Yeah, it's just creating this thing. Creating this thing results in that. I mean, I know what memset 128 will do. So I could just fill that in, but it's really like, why would it, what? Why would it generate a call to a function and then just like not insert that function into the exec or link to it? Does DMD itself do that? DMD code, excuse me. No, it's source, right? DMD source app.t. No. Ah, wait, well, I didn't pass by the C to it. So. Yeah. So that is just what happens. Okay. V. import. Predefs. Yeah. Okay, so that's called the Microsoft linker with no logo. Yeah. App obj. Yeah. Lib path. That is your lib path. Legacy STIO definitions. UCRT. UM. And then it just generated the call to this thing, even though it's not anywhere to be found. I mean, it is in the MSCC RT, like it's in one of those directories, presumably, unless it's in UCRT or UM or something. Okay, so we're not telling it not to link with the cstand library. And okay, so well, the only lib that it's linking with is just this one. So if we just pass more libs, presumably it'll do it. Maybe. Well, let's see. Where is the C runtime even going to be located? UCRT. Well, UCRT sounds promising. Well, that. Oh, is it lib UCRT or is it UCRT? Or is it UCRTD? Well, it's dynamic, presumably. Okay, so there's UCRT and lib UCRT. And well, this one's much bigger than the other one. So just that. Okay, let's just try to link. How do you do that again? DMD help. We want linker flags. List all GC allocations. Yeah, okay. Is it like -L or something? -L equals linker flag. Okay. Well, -L equals lib. Oh, well, UCRT. Let's try that. Okay, so UCRT is just here. Okay. Cannot find input file. Okay, now it's here. Okay, so unresolved external memset. Well, I mean, like it's mangled for some reason. Why would it be mangled? Lib. Yeah, well, so it found lib UCRT. You just can't find this symbol. What if we go into where the decompiler is? Wherever I installed it. DMD2. Yeah. Well, I mean, Windows is okay. RG and what is it, like mem sets? Like, okay, so there's going to be a lot of mem sets. No, okay, we definitely don't want HTML files, but specifically we want memset 128. Well, actually, let's just see what we want. We want memset 128 II. Well, oh well. D runtime source RT memset. Symbol Z memset 128. Incorrect calling of memset II. RTL sim D. Memset 128 II. Okay, let's see. What if we just Google that? Underscore memset 128 II. What on earth is that thing even? Okay, well, it is here. That's not what it's called though. And it's located somewhere. All versions of the C runtime libraries. Well, libucrt, yeah. Okay, so ucrt is DLL. Libucrt is not DLL. And this is C++ or something. Okay, this is startup. That's C++. All right. Let's see here. Can we list all symbols? So Windows list symbols in lib. Contents, yeah, dump bin symbols. Yeah, that sounds about right. Dump bin symbols. Lib ucrt. Yeah, that. All right. Well, I mean, that is going to be a lot of symbols, to be sure. But any of them can we pipe it to grep? Memset, like, is that possible? What's PowerShell equivalent of to grep? PowerShell. Well, actually, we have our G, right? Can we just click to that? Yes. Okay. Well, a lot of memsets. No memsets 128s though. Okay. What about libvc runtime? Is that even there? No. No. ucrt um. Oh god. So here we have cd dir cd x64. Okay, so that's a lot of stuff. vc run. No, there's no vc runtime here. Well, where is it then? Do we have a defined? I think we have a defined. fd. Okay, so it found ucrt, but vc runtime is not. I mean, vc runtime is gonna be in the Microsoft's compiler. But like, why would it jump? I mean, I suppose it's not really that. We could just insert one of ours. Like we could just do extern c. What is it? underscore memset128 II, like that. And oh yeah, return type, well, void or something, like, I don't know, what's memset supposed to return? Okay, so now, okay, well, oh yeah, I removed underscore, hold on. So now it builds in links. I kind of want to know what this is called with, though. Okay, what's this? Yeah, we don't need this anymore. We don't need that anymore. Let's close all of this stuff. This is where VS Code is running. Debugger, VS, okay. So let's create a new tab and then go to cd programs dmd to dir. Okay, we're looking for memset128 specifically. Void star p. So array pointer is a special thing here, okay. So it's not actually defined, it's just like, oh, that should exist somewhere. It links to something that has it, maybe. Well, actually, it might have it in memset d. Line 83, d runtime source rt. So, man, can we like, I don't know, can we get some context? RG help. I want some context. Type unrestricted version vimgrep. Type trim threads text. Stats sort smart search replace. Quiet pretty pre-globe pre-PCA. Okay. Only matching. Null, one file, no Unicode, no mmap. No line number, no messages, no file name. It's like, can we scroll like this? No. Mmap. So we want, I just want more lines around each match. Like, don't just print one line, multi-line. Well, no. Line, okay, invert, ignore case, ignore zero. Hidden glow, follow, fixed strings. Yeah, well, file, encoding, count matches, count, context, -c. Okay, -c2. So it actually does define it, but it defines it in the runtime, and I'm not allowed to have the runtime, evidently. Okay, interesting. Well, should we just copy paste it then? I suppose so. What's the... can we print full paths? Can we get... do we have like less or something? Or more? Yeah. We want what, full path? Oh god. Yeah, before each match. Well, I mean, I also want to search the thing. I mean, I guess what we could do is just add a folder temporarily. No, it's programs. No, programs, DMD2. Yeah, just add that whole folder. Yeah. And Control Shift F, mem set 128. Yeah, that's what I wrote. Nope, nope. Okay, well, we want case sensitive. Okay, all right. Now there it is. Yeah, I mean, that's all it does. That does make sense. Mem set 128 II. Yeah, I mean, this is it. This is it. This is all we want. Why are there two of these? So this is what we want, right? Except that we want it to be an external C. And, well, I don't know if that works. Yeah, that works. Note. This is from the runtime, which is runtime. Runtime should be disabled with better C, but it isn't. But the call to this function is generated anyway, which results in a link error. Okay. We probably don't need this. Remove folder from workspace. Yeah. Well. Well, let's see what happens there. Okay, so it is called, and it's called from here. Yeah. What's it called with? That is the pointer value, p start, p top, count value. That is one weird ass value. How does this even work with externcy? Interesting. So it inserts some memsets, but not this one specifically. Okay, well, fine. Fine, that works. Do we need this? No. All right. Well, we fixed that. Okay, so given. All right. Okay, so now we have an array, but we want to fill it. And so something like this is how you'd fill it. And let's just see what that does. Okay, well, that does work. I mean, oh well. Well, you kind of just want to have this array at compile time. Like, I don't want to write codes generally. Maybe we can do, well, can we? Well, if we just pull it into a function, can we just call that at compile time? Well, the function should return an array of, well, I mean, it should return an array, but we don't know how big the array is. and there is no like inference of length, seemingly, unless you make it into like a weird like template thing. I don't know. Let's try some. Let's try just. I mean, well, actually, maybe there is a way. Maybe there is a way. Like how? Like well, let's see. Long 3 temp. Long 3 result is 1, 2, 3. Return result. Does that compile? That compiles. Okay. Long 3 val is temp. So okay, if we could just infer in like this somehow, like that. Slice of static array temporarily returned assigned to longer lived val. Yeah, like how do you dlang infer array size? It's like is that even possible? See static array size inference. Yeah. 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 STD array, static array. No, 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 this is bad. No, no, it's just no. Yeah, like we definitely like what? Okay, apparently there is a discussion on implementing this. Static arrays with inferred length. Yeah. $sign. Well, did they implement the $sign? Let's find out. Nope. Okay, so it's just in here. Allow that. Well, yeah, like this is obviously what we want. Well, why is this not in the language? Reviewed version. Discussion. Community round 1. 8 pages. Please make it happen. Yeah. I mean, there is some weird STD thing that has a static array. Yeah, but yeah, this is just awful. This is just awful. So bad. Okay, so you can't infer an array size. Okay, so it has has more features. At least we have compile time things here. That's something. Okay, so this is not possible. This is not possible. You just have to know what it is. Can this be like a global? Like const temp? Like, is that something you can do? Yeah, seemingly. I'm guessing we're not gonna see it in the debugger though, because it's global. But we can write it out. Write do std out from it. Temp. Okay. output 3, yes. Okay, so we can make it into a global, at least. So that's something. Because if we make it into a global, then we can just return. We can have a function that returns a like string temp fun, like return 1, 2, 3. Like we can do this. Yes, and there is like that's not. Yeah. Count, well, I don't even know. Count of functions that count of just year functions. Oh god, count of solutions like this. Functions that start with year. This is ridiculous. Yeah. The result. Return result. Get. Okay, so this is count, right? And this is get. And down here, we can just do this. But we have to refer to it here, though. Functions that start with year. Man, this is like super awkward. Why is it like this? Okay, that we're not doing anymore. And here you would just have to iterate again. And just a result I++ equals member string of. I think you can just do that. Yeah. Well, actually, oh god, not I++. Member index. Yeah. Okay. Well, let's see what this. Okay, well, this did nothing. This did not do what it was supposed to do for some reason. The length is 3, so the length is correct. But whatever happened here, I don't know. It just immediately returns. It just immediately returns. Okay, why? What if we don't do member index? What if we do just our own index. So is that better? Actually, let's put a breakpoint just before return. I is 3, so it did iterate over this. And result, oh, and the result, now it works. Am I misunderstanding for each loops? VLAN tour. For each. Now, index is first. Member index. Okay. Index 3 is out of bounds. Oh, yeah, because we're filtering. Oh, yeah, so we have to do it with our own index. Yeah. Functions that start with year. Well, at least this worked. All right. Can this be made like this is so awkward. Why? Why? It's just come on. Can this be compressed in like oh god. I mean, I guess maybe we can just do this. Like, is that possible? Maybe. Yeah, that's possible. Okay, so we don't have to have a global variable at least. So that's something. Presumably it's only called once at compiler. Well, I mean, it's up to the compiler, I suppose, who wants to call it every time. Man, this is so awkward having to just have. Oh my god. I mean, in this case, I guess, like, how would you even express the notion? Well, well, yeah, maybe you would kind of have to do it this way anyway. Anyway, the point is we have functions that start with year now. So for each functions that start with year, we can call it just easily. Static even. Like, well, it doesn't have to be. It could be. Call functions start with year. We can just do what? Mixin func that. That's wrong. Cannot be read at compile time. Well, static. Oh god. But it can, though. But yeah, but it can, though. It can, though. Static cons? Like, what? Oh, there we go. Yeah, well, we want to slice off the this func thing. Okay, so all of this should just collapse into like a sequence of function calls. You'd think. What? Line is longer than 120 characters. Can we disable that? Dscanner style long line. Yeah, I think there's a way to disable that. X D, what is it? Code D or something? Yeah. Scanner. Yeah. So what are we disabling? Dscanner.style.longline. Long line. Yeah. Don't care about long lines. It's fine. It's fine. It's also highlighted as if it's not used, even though it's used right here. So man, this is like, well, I mean, I guess it's not so bad. You do have to repeat the loop though, which is yeah, I don't see how you would avoid having to repeat the loop. Because you want to know how many entries there are, and then you want to fill those entries. And if you could just say if you just had inference, well, no, that wouldn't be enough. You can't really count entries in an array and also fill the array at the same time when you already have to know how big it is ahead of time. So yeah, you do have to loop twice to get it like that, just to get the array of strings that has the function names. So we don't need this call all function. Let's start with year thing. Mem set 128. You know what? I'm just gonna put it like out of sight somewhere. Like here. Does that work? Yeah. I mean, yeah. Yeah, these have to be pulled out into function because we have to statically know what this array is. Okay, so compile. Yeah, so that works. But can we, now that we have just an array of strings that we can just call like this, can we remove some of that boilerplate for one? Well, we do have auto, so these functions are free to return whatever they want. So in that sense, yeah, well, let's do string input. Let's make it so they take input rather than unable to write the file. Well, do it anyway. Yeah. So here where we are calling them in this loop. So instead of function, we'll just have func. Yeah, and well, input. App main input already defined. Oh, because this isn't the scope. Oh my god. Yep. Okay, so now it takes input. Yeah. Okay, so we just call them in the same way. We read the input, we call the function. So this should work the same. Or not. Read entire file. Oh. Yeah, because input R 2022 day one. Yeah, there's all sorts of weird things going on there. Yeah, because it's got quotes in it and such. So really, it's func. Well, actually, let's see. Get input. Yeah, we also need to slice off the quotes. But which, to be fair, get input is only called in that one place. So we might as well just, just call it. Just name, input path, content. Input content. How is debugging this? Oh god. Yeah, for some reason it just doesn't always listen. Year 22, day 1. Okay, well, so far it's okay. Just name is 2022, day 1. Input path is not anything. And input content, it couldn't read it. Okay, well, just name worked fine though. Yeah, it's here. Well, handle is invalid. Yeah, we know that. Path 0. Input 2022 day 1 .txt. Yeah, that's Oh wait, did I slice off here? Yeah, I sliced off here for some reason. Okay. Well, I'll just put the year back in. Yeah. Okay, so funk is year 2022, day 1. Wait, hold on. Wait, it's year 2022, day 1 with... Oh, the module name is already sliced off. Interesting. No quotes. So that's all we gotta do. Okay, no, well, this is not exactly... well, I mean, it's okay. It's okay. No quotes. There's 2 of these. Okay, well, why are there 2 no quotes? No, wait, there are 3. Is it because we're iterating through this 3 times? Well, I mean, it kind of works. I don't know why it switches to disassembly though, but it kind of works. These are scoped, except they're not scoped. Okay, well, the debugging is not great, but like, this is workable. At least we see the things. Kind of. Wait, did it print the appropriate things? Let's run it again. Yes. Yes, it did. Is this possible? Requires GC. Well, what if it doesn't though? What if it doesn't though? Static const. Okay, well, it's not a literal. That's the problem. Well, we're probably gonna remove this anyway, because we're just gonna do 1 write per function or something like that. No quotes cannot be read at compile time. Yeah, but it can though. There we go. Okay, I think that's working. I think that's fine. Let's see if that runs. Yes. Runs fine. Well, can we have these functions, these year functions, return, instead of printing, well, I mean, this does let us run them on smaller inputs, just on its own already. So So we don't really need to worry about it that much. Um, mm, all right. So what did we even? Okay, toggle toggle focus on the primary sidebar. Yeah. We removed input reading, and we removed the get input function because we inlined it. Count all functions start with here. So these are these have to be functions because we're calling them at compile time. That is just a weird debug. And this is just an inline. Print the function name, read its input, call it with that input. And that's it. Yeah. Have year functions take strings as input. They can also return, instead of printing, they can also return things, I guess. But we only really want that. Like, the reason why I want them to be able to take strings is because when you're writing one of those functions, it's useful to be able to like call it with some string, right? And then in the debugger, you can just like stop there, like compile, and then in the debugger, well, is the syncing? No, syncing is working. And in the debugger, you can just stop here and it'll probably assert because the it's supposed to be all integers and not. Yeah, see, well, one problem, another problem I have is how asserts work. It's like assert just stops like somewhere, you know, and you have to hunt up the call stack to see where the actual assert happened. At least the line number seems to be accurate, so that's better than C macros. Okay, so that problem is solved. Can we solve the assert problem? Well, first of all, first thing we're gonna need is dlang debug break. Like, we want a debug break. C++, yeah. Well, debug break, that's a compiler intrinsic, I'm pretty sure. Okay, do I have to add the add folder to workspace? Programs DMD. Okay, let's look for debug break. Okay, WinBase. Well, I mean, there is a function this way on Windows. There's a function. But is there an intrinsic? Okay, int3. Okay, we want whole word. CDB gen. That's the backend. CD hold. Func call. CD hold. Isn't code gen hold. Code x86 int3. Static struct int3. Op call. Unit test. Okay, well, this is clearly not. This conversions. Do we not have a debug break intrinsically? What is this shit? Do we have a, well, there's a trap, right? There's a trap intrinsic. Well, that's like in elsewhere. We do have inline assembly. And inline assembly. Inline assembly. ASM pure, no throw, trusted, no cheese. Oh my god. Do we have an example? So it's just ASM in, okay. Well, let's do that. Let's do that. Like right here. ASM in 3 or something. What's wrong with this? Mismatched number of curly braces, okay. Is it semicolons? Well, it's not an empty statement exactly. Hold on. Align even db. Okay, hold on. God. Pop ebx. Like, well, if I just write pop ebx, like, does that semicolon? Does that compile? Wait, that's not. Yeah, there we go. Okay. Okay, what's the syntax for int3? Is it just int3? Opcode expected. Ah, it's what we were looking at before. Is it like that? I mean, that does look like an opcode to me. Jump, compare. Well, pop is an opcode, for example. Yeah. Okay, is there, I mean, int3 just looks like an int3 here. Well, not int3, it's int 0x29 specifically. Ah, so it is an interrupt. Is that, yeah, so, okay, so that works. Well, kind of. I mean, this is 0xcc. So, I know, is there a 0x29 in anywhere? No. Code x86. Hold on. ASM in 3. Is there some docs for this? Int x86 instruction. Yeah. It's a 1-byte instruction. Zero xcc. The opcode for int3 is 0xcc. Yeah. Okay, well, if we do this weird 0x29 thing, is that even what's that gonna do? Well, it does appear here as like literally that. Okay. Well, that worked. X64 assembly reference. What's 0x29? Int to match case whole word. Int n. Okay, so int3 is an instruction. Did this just leave me to the same? So not, the interrupt is enabled. Yeah, okay. Where? Oh my god! What on earth is this? Okay, so int3 is an instruction. Like it is an opcode. Well, kind of. What's int3? What's 0x29? What on earth is that? What's 0x29? Oh god. Okay, that is a lot of stuff. Flags affected. CD IB. CD29, yeah. Not CC. Oh, yeah, not CC. Okay, we can't get over that. Fatal program X. Oh my god. Oh. So this is actually a fatal program exit. Ah, so that's not a debug trap. That is okay. So this and this are different. Like interesting. Okay, so how on earth do I generate CC? And where do I get these generate software interrupt specified by the immediate byte? And where do I get a list of those? See the section title interrupt and exceptions. Okay. X64 interrupt table. Was dev wiki? Well, okay. I want a table. There's no table here. This is not a table. Interrupts. Interrupt descriptor table. This is not all of them, clearly. No. Yeah, interrupt vector table. Interrupt number in hex. Reserved for DOS. Okay, DOS interrupts. DOS interrupts. what is this? Well, it is 4C. Reserved for DOS. Reserved for BIOS. Well, 29 is in there. So this is like a Windows specific or something? Okay. All right, whatever. So we want to generate this CC instruction somehow. So, and in3 apparently is not it. Int is it, but that's a different instruction. Asm instruction. Align, even, naked, db, dq, opcode, operand. Naked. What's naked? Okay, well, I mean, can we just do db 0xcc? Is that something we can do? Seemingly. Okay. Ah, there we go. int3. That is an int3. That is an actual debug trap. Amazing. Okay, so this is where we are before the function call. Call add. Okay, now we step over that. Add to the stack pointer. int3. Well, I mean, we kind of want to run through that. Okay, that works. Okay, so it stops here. Can we, like, oh yeah, because the debugger inserted its own int3. Hold on. Yeah, that works. Okay, so this right here is the debug trap. Just asm dbcc, just that. Yeah. Can we replace an assert with one of those? I think that naked thing, the snake, oh god. In my assembly programmer. Opcodes supported. All of these opcodes are supported. And I wonder if SIMD is actually supported. Well, AVX, what about AVX 512? Well, I guess you can just, I mean, you can insert bytes, right? So you can write AVX 512 instructions if you really want to. Okay, where does naked go again? Naked goes, that's an ASM instruction. line, even, naked. Opcode, identifier, int, in, out. Labels, even, to line, yeah. Opcodes. Register 64. XMM, but not ZMM. Lock rep. Okay, well, what we want is something like bool condition is false if condition, then don't do anything, right? Else do this. But we want to put that into a function somehow. I mean, we could put it in just a normal function, like void assert2 bool condition. And well, I mean, at this point, since it's a normal function, we can just do if not condition. Yeah, that's all we do, right? Assert2 cond. Yeah, this is still not great though, because it stops here, which is still one level above where it's called. Not good. Not good. Yeah. Well, so D has mixin templates, but those don't really take conditions, they take types and only types. They don't take values. Oh, maybe they do. D lang mixin template mixins. Identifier template parameters constraint. Template parameters type value can take an argument which can be statically evaluated. Template foo string. Okay. Mixin template. Declaration expected. Huh. So you have to declare something in the template. You can't just not do that. Creates bar. Huh. Hmm. Yeah, so it's the template itself that's like it can't just insert arbitrary code. It has to declare something. Yeah, there's still gonna be debug info for this though. So yeah, I don't think there's any way to make it stop at the assert specifically. Other than literally calling this. Other than literally calling mixin. Yeah, you would have to do something like that, right? It's like mixin, you know, if not if well, if condition because this would be the parameter if you were to do it as like a mixin macro thing. And this would have to be a parameter to that macro. And like this, that's an error still because cont can't be read at compile time. Well, yeah, but like as a parameter to a macro, it would be sort of able to be read, presumably. I don't know, this Dylan mixin macros, like mixin macro pattern. That sounds like what we want. Value op RHS value. Mixins plus compile time op binary string op. So this op binary thing is like a macro, kind of. Yeah, so op binary is this macro thing. Depending on what it's called with, it returns different things. Okay. Okay. Can you, all right, so that compiles, right? So does that work? Yeah. Okay, how does that work again? Okay, so this can be anything. Alias name. do you have to pass it like the name or something? Like, what is this? Well, normally this is like a type thing, right? It's, yeah. And I think this is the same as like, I think this is the same as a template that returns a function. Hmm. Yeah, so that doesn't work. Yeah, there's probably no way to just make it insert some code. Still don't think there is. No, let's see. String mixins, yeah, I read that. Mixin macros, so tantalizing. Ah, so we have token strings as well. Yeah. Mixin alias foo. Mm. Mm. Yeah, I don't think we're getting this to work really. So yeah, asserts are gonna have to just be asserts. And yeah, not good, but at least there aren't any gotchas with them. You just kind of, and they print messages, so like assert false here will actually print a message. Well, and there's some compile time checking for some things. Assert, well, actually, you know, it's like long x equals 1, assert x equals 2. Okay. Oh, what just happened? There it is. And we have a message. Yeah, it's kind of deep. Well, at least we have a message. That's something. Okay, no changes. No. What time is it? 15:23. All right. Do we want to do this today? Nah, probably not. Leave it for later. All right. So these year functions now take strings as inputs. So you can call them with smaller inputs while writing them. We've changed how this code is generated. And now we just get an array of strings, which is all the functions that start with year, which is generated at compile time. So that's good. I mean, I don't know if this specifically is good, but it's good that we can do that. It would be even better, well, it would be good in general to have inference on array length, but in this specific case, I don't think it would help, because we kind of still have to iterate over all these functions twice, because we need to figure out how many we have, and then we need to fill in their names. Yeah, I don't think there is any real way to like put this into a function, because the inner part of the loop is different. Yeah, the inner part of the loop is different, so yeah, can't really, yeah, can't. I mean, unless there is some clever way to pull this out, like it would be nice to be able to have something that somehow compresses it, and so we just write this, like, you know, like iterate, and then in there we just write like this, you know, somehow, but again, that's a macro. It's like we want to just insert a macro that writes this, then this, and then this. And I guess we can kind of do it, maybe, because this is, oh god, this is just like, if we wrap that into a string, if we wrap that into a string and then like, yeah, that is just awful, of course, but if we wrap that into a string and then we wrap this into a string and then we like do mix in string part 1, then like this, and then string part 2. Oh god, yeah, this this would just be, I guess this would do, this would be like a macro. Oh god, oh man, good luck debugging that. Yeah, but there isn't really any equivalent of like found define this, then expression, then 3 closing curly braces. I don't think you can just do that, because there's no like super generic macros. There is only compile time function evaluation and mixins. There's also macros, but macros basically generate, not macros, templates. Templates just generate declarations, like function declarations. So we have templates for function declarations. We have mixins for just arbitrary code construction out of strings. We have compile time function evaluation. What we don't have, seemingly, is a macro system where you can just pass an arbitrary expression into it and have it insert that arbitrary expression inside a block of code. Which is why, for example, you can't really do an assert the way I would do it in C, like one debug. Like, because this condition, this is basically just, this could be anything. It's like assert, call function, call x equals 5. Like, yeah, so what this kind of bound define does is it takes an arbitrary expression and puts it like inside of this, which is another kind of arbitrary expression essentially. And these kinds of macros are just unavailable in D. Yeah. All right. Actually, what build types do we have? Dub, build types. Build types. Debug, release no bounds. Unit test, docs, profile. Inline no bounds check. Can you turn off asserts? Well, let's find out. Assert false. Well, x equals 1. Long x equals 2. So this will assert. Here. We get the message. Yep. Now we go into dub.json and we go build type. Build type. Well, actually, no, it's task, right? Yeah. Build type release no bounds. Oh, so it does avoid all of these are zeros though, for some reason. Why are these? Wait, what just happened? Debug. It's compiled in debug. Let's remove those. Well, okay, so that works. Release. Forming debug build. Before. Yeah, there we go. Performing release build. Okay, this is the release build. All of these are zeros. A release build's just broken? What? Like, that is not what it's supposed to print. Well, if release builds don't work, and also we have to insert our own runtime, then the language just doesn't work. So this is worrying. This is worrying. Why are these zeros? Oh man, this is really bad. Oh man, I mean, this is printed correctly. But then all the answers are just zero. What? Oh no. Oh no. Oh. Can we stop just, well, actually, maybe it's a debugger problem because I'm doing output debug string. Let's see. Build. No, we kind of want to remove that. Oh my god, what? Yeah, okay. Build Dadland. It doesn't print anything. It doesn't print anything. It just returns immediately. Write to stdout temp. Performing release build. Yeah. It doesn't write anything to stdout. Oh. Okay, well, what if we do build type debug? Now it writes stuff to stdout correctly. Well, that behavior shouldn't change in release builds. Yeah, see, this doesn't print anything. What? Does it like just fail instantly or something? Ah. Yeah, so something is definitely busted about release builds, evidently. Some kind of access violation. It never, like, we can't even examine anything because it just failed instantly. As soon as we tried to write to stdout, it just kind of failed instantly. Like, I don't think any of this will work. Well, maybe if we compile with release with debug info. Release debug. Yeah. Release debug. Okay, there we go. So now at least we're getting some kind of error message thing. Not that it's stopping. Okay, so it is a mem copy. There is a null pointer somewhere. Debugging new process. We can't evidently. There we go. Okay, so this is. Oh my god. Call stack. Okay. So we go in here. Let's try to step through. Okay, it goes into alloc immediately. And then to oh no. And oh god. And I'm guessing that yeah, well, I mean, if the debug build works and the release build doesn't, then the compiler just doesn't work. Like, they're not supposed to be that different. The compiler just doesn't work. Why does it call memcopy right away? Wait, did it reorder these? Is that what happened? Yeah, these are not supposed to be reordered. What? And did it just remove this because it's like, yeah, that doesn't do anything. Oh man, that's what is that what happened? Is that what happened? It's like, you know how you alloc vmem before like writing stuff to it? Well, you know what if we do it after? What if we do it after though? Like, no, don't do it after. Okay, at least see that it does a bunch of things here, including a call to memcopy, and only afterwards does it actually alloc vmem. Yeah, so this is virtual alloc presumably. What? How is the compiler even allowed to do that? Is it because of its weird like garbage collection based memory management? It's like it just assumes that every buffer is safe to write to like all the time or something? What? This is insane. What? Okay, so if we just step through the disassembly, move. Now, see, we go into alloc. We go into alloc before we call virtual alloc. Wow. Wow, that's bad. Holy sh. Okay, so we can't use the optimizing compiler. we can't use this compiler. It reorders our stuff way too much. Oh my god. In fact, it reorders it so much that it's just unusable. Okay. I mean, there are 3 compilers, and 2 of them can be used on Windows. So that one, right? Releases. We want Windows x64 7-zip. Yeah. Let's try this compiler. Maybe this compiler actually works. Oh wow, okay. Why? Why would you reorder that? There's system calls. Does it not realize there's system calls or something? Yeah, let's just reorder your system calls. Why not? You don't need that. You don't need that. Okay, so this is what goes into variables. Edit. Okay, let's delete that. Let's insert that. Okay. Now, DMD should not work unless there's a version of it here. Oh, yeah, we have to restart. Restart everything. No, not that. Code.vent. Why do we have 2 of these? Why do we have 2 of these? This is not. I don't want that. Don't save. Okay. Okay, so DMD should not work. So this should presumably fail. Or not. Okay, how does it know? How does dub know that this is where the compiler is? Is it the code? Wait, I think you can change the compiler here. Oh no. Oh wait, is it in, oh god. Is it in task? Problem matcher, build type. I think here you can choose compiler, LDC or something. No. DC2. Yeah, so now we just need to figure out. Okay, so LDC2 is the compiler. Wait, hold on, let's make sure that we can actually run it. Yeah, we can. So dub docs compiler. Build settings, is it here? Like compiler. Oh wait, is it? It's maybe I'm using the wrong. Oh god. Settings. Oh yeah, so this is in. So that's fine. That's fine. DMD path. Well, yeah, but that shouldn't work. Is it? Dub. Okay, so this ran the normal one. Yeah. Dub compiler dmd.xc. Let's remove that. Ah, let's remove that as well. Ah. Exit run. What do you mean exit run? Huh. Ah, so now it's correct. Now it's also correct. So that's fine. Using this compiler. Dub run build release debug. Huh. LDC2 source app.exe. Okay, well, it printed temp and then immediately exited. So presumably it just failed. So this probably has the same problem. This probably has the same problem, which is that it just doesn't order things correctly. Okay, well, this is different disassembly. This is where we allocate virtual memory. Yeah, so this is the call to virtual alloc, presumably. But before we get there, so this is write to std out. Oh, wait. Wait, this would not work anyway, because write to std out. Yeah, I think this fails correctly, actually. Because the core, what do we, can you, yeah. This fails correctly because write to std out will call into this. Yeah, so this fails correctly. Well, we can just turn that off temporarily, right? We can just do write to std out. Yeah, just don't do that. Yeah, and it still doesn't work. So now write to std out definitely doesn't allocate anything. Yeah. Now if we go to tasks, so if we do release, if we just do debug, and it also doesn't print anything. What it does actually. So that's all good. Debug release. Yeah, this is failing silently. Install. Okay. This is virtual look. And for what's worth, this seems correct. It removed this call completely. It's just gone. It's just gone. It's like, you know, that file writing you were doing in, yeah, you don't need that. You don't need that. See, it's not anywhere in here. Apparently that we also don't need. Yeah. Yeah, it just removed like all my code. It is calling these functions. It's not doing that. I am doing anything. These functions, like this input. Yeah, they aren't doing anything, but it is calling them. Okay, well, it's doing something. Like there is some kind of loop involved here. Now this is just memcopy. It definitely did remove all of the output. Yeah, there's nothing. So it kind of works. Okay, so this one's not failing. This one's not failing. Yeah, exited with code 0. So it did reach return 0. Whether it actually did anything before it got there. Well, we know it removed all of our write file calls. Those are just not happening. Like, no, they're just, because they're in an assert. It removed the asserts, but it did not keep the expression inside the assert. So that's why it, well, it still doesn't explain why it didn't call this in time. Well, okay, so that explains some things. Okay, so maybe the compiler does work after all. It's just the asserts that are busted. Well, if the asserts are that busted, where whatever's inside the assert will just go away, then we can't really use them. We have to have our own assert, after all. Void assert2. Like, I can't really define an assert because assert underscore bool condition if condition, or rather if not condition, asm db 0xcc. And every assert, apparently I have 61 of these. Oh my god, okay. Well, every assert needs to be replaced. Not globally. Every assert needs to be replaced with assert underscore. Of type int to parameter bool isn't 0. Is not callable. Or null. Read file. Well, that's just isn't 0. No, we're not really interested in that error. What's the error? Assert false unreachable. Just assert false. Okay. So that actually is working fine. Okay, so the assert, the built-in assert is not great. It's not great. It's actually just really bad. Why would it just completely remove the thing that's inside of it, though? Like, can you imagine, right? Just constantly being afraid of writing assert side effect. Like you're just not allowed to write that? Like, what? What? Okay, so maybe the compiler isn't busted after all. Maybe, or maybe it is. Does this work? Oh god, no, that is. Yeah, so it just exits when it encounters a debug break. Oh my god. Oh dear god. Assert is a keyword. so let's try going back to the original compiler, which is what is it? That one. Windows bin 64, presumably. Path edit. Let's remove that. DMD2. Yep, okay. Okay. Well, I mean, you're gonna have to relaunch everything again. Oh god, what? Code. Try, okay, no, was it that then? Yeah. Yeah, so that compiler worked just fine. It's the assert semantics that. Oh god, why would the assert work like that? It's like, okay, sometimes well, most of the time, I do call the assert with something that doesn't have a side effect. But sometimes I don't. Okay. Now the next thing to do would be to verify. What does this bool? Read file result. Yeah, see, that works. That's release configuration. Okay, so the other thing I want to verify is this shouldn't trigger. Yeah, it just gets removed. But in debug builds, let's do it twice. Yeah, in debug builds it doesn't. So release. Yeah, the assert gets removed. Oh, man. Oh my god. Okay, so asserts do get removed in release. Okay, so no, it didn't reorder them. It was just, it was allocating before, because I was calling std out, which allocates here on Windows, just so I can see stuff in the debugger. So that wasn't the problem. The problem was that the asserts made it so all of that write file, read file code just went away. Well, I mean, out of the however many 61 asserts that I have here, there were only 2 with side effects, so presumably it's not that important to be able to write an assert with a side effect. So, oh god. Tasks JSON debug. Is that debug? Yeah, that's debug. Okay. Remove side effects from asserts. Yeah. All right, that's enough for today.